So in this video we are going to revise acids, which is CC8. Hopefully everyone is familiar with this by now. Acids all produce H plus ions when they are dissolved in water. Okay, so I've got an example here of 3 acids. I know they're acids because they're all giving me H plus ions. And you can see in beaker 1 that I've got 5 H plus ions, whereas in beaker 3 I've only got 1 H plus ion. Okay. We would say that the acid in beaker 1 is more acidic than the acid in beaker 3. Okay, and it's more acidic because it's got more H plus ions. Okay, the more H plus ions an acid has, the more acidic it is. Okay, the more dangerous it will be, the more corrosive it will be. Okay, if you've got a really acidic acid and you spill it on your skin, it's going to be corrosive. It will burn through your skin. Okay, if you've got a less acidic acid with not as much H plus in there, it might just irritate your skin. Okay, and when we're talking about the acidity of acids, we use the pH scale. Okay, we've said that this is the most acidic acid because it's got the most H plus ions. The most H plus means it's got the lowest pH. Okay, remember a neutral pH is 7. Anything less than 7 is acidic. And the further you get from 7, the more acidic it's going to be. So pH equals 0 is going to be the lowest pH. If I was to put a pH on this guy, I could say pH equals 3. Okay, it's still less than 7. It's still an acid, but it's not as acidic as beaker 1 because there's less H+. If it's not as acidic, it's got a higher pH, a pH closer to 7. Okay, and then this one here, it's only got 1 H+, I'm just going to call it pH 6. Okay, so all pH less than 7, this has the lowest pH because it's got the most H plus ions. All right, if you wanted to measure the pH, there's 2 things you can do. You can use indicators. Okay, and indicators are just substances that change color. So for example, universal indicator. And universal indicator is a different color in an acid than it is in something neutral and than it is in an alkali. Okay, so universal indicator will be red in an acid. If you put it into something neutral like water, it will be green. If you put it into an alkali, it will be blue or purple. Okay, so indicators just change color depending on the pH of the solution. You can also use something called a pH probe. Okay, which is like a little electronic device that you would pop into the beaker and it will give you a reading. Okay, and these are more accurate because you can get the pH to even up to 2 decimal places. So when you're using universal indicator, you add the indicator to the beaker and it turns red, say, and then you've got a chart and you have to compare the shade of red that your acid has turned to the chart to see what the pH would be. Okay, and that's not always entirely accurate. It will tell you it's an acid, but it's hard to get an accurate pH from an indicator. On the other hand, the pH probe, a little electronic device, is slotted into your beaker and you'll get a reading, a digital reading, and that will be accurate to within 1 or 2 decimal places. So this is a much more accurate reading of pH. Okay, you can see that obviously there's a different pH on my acids A, B, and C. Okay, there are 2 main factors that will affect how much H plus an acid has. Okay, and they are the strength of the acid and the concentration of the acid. The strength of acid, concentration of acid. When we're talking about strength, we are talking about the dissociation of the acid. Okay, so for example, HCl is strong because it fully splits up. So when I say dissociate, I just mean splits up. So HCl, hydrochloric acid, if you dissolve HCl in water, it will fully split up. Every single HCl molecule will split up into a H plus ion and a Cl minus ion. And remember, the more H plus ions you've got, the more acidic it is. So when it splits up to give you H plus and Cl minus, when it fully splits up, you end up with lots of H plus and you end up with a low pH. If I used a different acid, a weak acid, okay, that acid wouldn't fully split up. You might have 1 or 2 molecules that will split up and give you H+, but the rest of the molecule will just stay together and you end up with a lot less H+ in your acid, okay? So the other thing then is concentration of acid, and by that I just mean the amount of acid molecules that you have dissolved, okay? So remember, you're always dissolving an acid in water. Always, acids are always aqueous. You're always dissolving them in water. If you dissolve lots of HCl molecules in water, you're going to have a very low pH. If you only dissolve a few HCl molecules in water, then most of your acid will be water and you're going to have a much higher pH, okay? And remember, there's a calculation we looked at, okay? If you had an acid that had a pH of 2 and you diluted by a factor of 10, your acid will end up with a pH of 3, okay? If you started out with an acid that had a pH of 0 and you diluted it by 10, your new pH would be pH 1. And when I'm saying dilute by 10, I mean you're adding more water. You're making it more dilute by adding more water. If you started off with a pH of 4 and you diluted it by 10, you would get a new pH of 5. So in general, I can summarize all this, that if you dilute an acid by 10, you are going to increase the pH by 1. Dilute an acid by 10, you increase the pH by 1. And by dilute an acid, I just mean you're going to add water. So if you had 10 mils of the acid and I want to dilute it by 10, then I want to go from a volume of 10 mils to a volume of 100 mils, because that's diluting by 10. So I'm going to add water to my acid to bring it up to 100 mils, and I've diluted it by 10. Okay, dilute by 10, you increase the pH by 1. Okay, so that's acids. We also need to look at the reactions of acids. Okay, and typically we're talking about the reactions of acids. We are either reacting acids with bases or reacting them with metals. And we look at acids and bases first. If you react an acid with a base, you will get a salt and you will get water. And this is called neutralization. And the reason it's called neutralization is because you're producing water, which is a neutral substance, okay? So you need to know how to name your salts, okay? So this is in your core revision booklet, and I'm on page 18, which is the acids page, okay? And it tells you that the name of the salt will change depending on the acid that you use. So if you're using hydrochloric acid, the salt will end in chloride. If you switch to sulfuric acid, you'll make a sulfate salt. Nitric acid, you will make a nitrate salt, okay? So I'm going to give you an example. If the acid, I'm going to stick with hydrochloric acid, if that's the acid that I use, hydrochloric acid, and I react it with a base, okay? So on your guide, I tell you what bases are, all right? Bases are either metal oxides, metal hydrox, and metal carbonates, okay? And by that, I just mean if you put any metal in front of the word oxide, so calcium in front of the word oxide, that's a base. Any metal in front of the word hydroxide, so sodium, you've got a base. Any metal in front of the word carbonate, so sodium again, in front of the word carbonate, you have got a base, okay? So I'm going to pick a base. I'm going to pick a metal, magnesium, that's a metal. I'm going to stick that word in front of oxide, and I've made myself a base, hydrochloric acid and magnesium oxide, okay? The salt, the first word of the salt, you always get from the metal of the base. My metal is magnesium, so that's the first word of my salt. The last word of my salt, I can see from this table here, is going to be chloride. So if it's hydrochloric acid, the salt ends in chloride. And then I also make water, all right? You need to be able to name your salts depending on the acids and the bases that you are given, okay? This one, a common mistake with this one is for the ending of hydrochloric acid. I often see students write hydroxide as the ending. I think they see the hydro there and then they know the word hydroxide, okay? The ending of hydrochloric acid is chloride, all right? Just one thing though, if I were to use, I'm going to just do one more example, sulfuric acid, okay, it's an acid. A base, I'm going to pick a metal, calcium, And this time I'm going to end it with the word carbonate. Remember, oxide, hydroxide, carbonate, they are all bases. All right. I'm going to form a salt. The first word of the salt comes from the metal of the base. So that's going to be calcium. The second word of the salt comes from the acid. If it's sulfuric acid, my salt ends in sulfate. Plus water, plus, okay, carbon dioxide. If your base is a carbonate, you get an extra product, okay? You still get salt, you still get water, but you also get carbon dioxide. You get an extra product, and that's only if your base is a carbonate, okay? So because you're producing carbon dioxide, you are going to see bubbles, all right? It's a gas, you're going to see bubbles, all right? And if you want to test to make sure that the gas being produced is carbon dioxide, okay, you are going to bubble that gas through lime water. And if the lime water turns milky, then you know your gas is carbon dioxide. Okay, so lime water turning milky shows you that the gas is carbon dioxide. All right, these are all examples of acids reacting with bases. There's another set of reactions you need to know, and that's just an acid reacting with a metal. Okay, so instead of reacting an acid with a base, you're going to react an acid with a metal. You're still going to make a salt, and you're going to name that salt in exactly the same way, but instead of making water, you are going to just make hydrogen, right? So let's look at an example of that. I'm going to stick with sulfuric acid, so that's my acid. Okay, when I'm doing a metal, okay, I just pick any metal from the periodic table, okay? I'm going to stick with calcium. And because this is a metal this time and not a base, I'm just going to write calcium, and I'm not going to write the word oxide, hydroxide, or carbonate, okay? If it's a base, you've got the metal, followed by the word oxide, hydroxide, or carbonate. When it's an acid and a metal, you just write the name of the metal. You don't write a second word. It's just the metal from the periodic table. All right. And when I do this reaction, I make a salt. Okay. So I take the name of the metal, just like I did before, calcium, and I take the name of the acid and I get sulfate. So you can see that I'm forming exactly the same salt. Whether I use calcium carbonate or just calcium, I'm still going to get the same salts. Okay. But the rest of the products are going to differ. I'm no longer getting water. Now I'm just getting hydrogen. Okay. Hydrogen is a gas. Okay, so again, if you're making this product, you're going to see bubbles. And if you want to test for hydrogen gas, okay, and this is always a 2-mark question. Hydrogen is the squeaky pop test, but you can't just write squeaky pop. You have to write about the lit splint, all right? So hydrogen gas doesn't just randomly pop. You have to ignite it. So what you'll do is you'll take a splint, which is just those little pieces of wood that we use to light the Bunsen burners. You'll light it on fire, so a lit splint, and then you'll put this lit splint into the test tube where you think the hydrogen gas is being produced. Okay, you don't plunge it right into the solution. You just hold it over the solution, and that's releasing the bubbles. And if you hear a squeaky pop, then it's hydrogen gas. So to get the marks on that question, you'll have to write lit splint, squeaky pop. If you just write squeaky pop, you'll get 1 mark out of 2. So carbon dioxide, lime water will turn milky. There are your 2 marks. 1 for lime water, 1 for turns milky. For hydrogen gas, a lit splint and a squeaky pop. Okay. The other thing I'm going to mention about acids is in this reaction, these neutralization reactions, you are making a salt, okay? These salts are typically soluble in water, and you can be asked how you're going to get the pure, dry salt from the water, okay? So you do the reaction, okay? You do the reaction and you are left with salt and water. So if you reacted your acid with your base and you have formed salt and water, okay, this salt is aqueous. That means it is dissolved in my water, okay, and I need to get my salt from my water. So how do you separate a soluble solid from a liquid? That's what you're trying to do here. You're trying to separate a soluble solid from a liquid, okay? And if you're trying to do that, you are going to use, you can write evaporation or you can write crystallization, okay? You are going to heat, so you're going to have this in an evaporating dish, okay? And you are going to heat, you're going to heat your salt and water. So I've got salt and water in there. And you're going to heat your salt and water. And what's going to happen is all of your water will start to evaporate. So your water will turn from a liquid to a gas and it will evaporate. The salt won't. Okay, the salt will stay solid. And when you evaporate off the water, you are just left with the salt. So you have to write heat. Okay, when you're doing this, however, it's important that you don't heat it really quickly and evaporate the water really quickly. If you evaporate off all the water really quickly, you just end up with mush. So you're going to heat, you're going to evaporate some of the water, and then you're going to turn that heat off and you're going to allow the rest of the water to evaporate slowly. Evaporate slowly. And the reason you do this is because you'll form larger salt crystals if you let the water evaporate slowly. And then you're going to leave your salt crystals to dry. Okay, so you're left with salt and water. You need to evaporate the water. You need to mention that you heat to evaporate and that you evaporate slowly so that you get large crystals, which you will then leave to dry. Okay, so this is how you separate a soluble solid from a liquid. Okay, if you still had bits of solid floating around first, okay, so just say you've done your reaction, you've used excess base, and your base is a solid, and you've got lots of solid floating around at the start, then before you would do this step, you would filter. So you filter to remove any solids. Remove any solids using a filter, and then once you're left with just the salt and the water, then you're going to carry out crystallization. Okay, so in your core revision guide on acids, okay, so this is all stuff that you need to know, and I've written out that separation process for you. Okay, there's also some practice questions here in your guide, which I would recommend do. Although I do think we did these for homework, didn't we? I would recommend doing these questions for yourself. All of the answers are included below. Okay, so do the questions to test yourself on what you have learned, and then mark your work. There's no point in just looking at the answers. You might think, oh yeah, I do know that. It's not testing yourself until you've actually written down an answer. Okay, it's obvious when you look at the answer, but would you have gotten that answer yourself? Okay, please do the practice questions and then mark your work rather than just looking at the answers and thinking you know it all. Even that 6-mark question, okay, I know they're a pain, but just practice it and make sure you get it right. Practice writing it out and then mark your work. Make sure you've got it all right and that you're not losing any marks. If you've got questions on your answer or on my answers, then just message me on Teams and let me know.